everyone. Welcome to another edition of Patio Productions, where we just give you the latest and greatest news all about pre-calculus. So we are doing another lesson today. We're going to be doing section 3. And today we are going to move on to learning about not just sequences, but now we're going to sum up our sequences. And so our new word of the day is going to be a series, okay? So fun, so fun. Love it. Series today. So let's get started with this lesson. As we're doing this, I'll have a little quick chat here, guys. Don't forget that you're supposed to be taking pictures of your homework. You're supposed to be submitting them through Google Classroom. If they're a little bit late, still turn them in, guys. I definitely want you guys to turn those babies in. So let's get started here. Okay, so today's title is so fun, so exciting, arithmetic and geometric series. So we are specifically talking about those two kind, arithmetic and geometric. We're also going to talk about some new notation today. So fun, so exciting that I cannot wait to introduce to you guys. I just want to mention that you're not supposed to be afraid of the notation. We've talked about this lots of times in mathematics, that we just need to, practice with the notation. And I think that's going to be amazing. So let's get started. Okay, so just as a quick definition, okay, a series is the sum of the terms of a sequence. So remember, a sequence is a list of numbers that has a pattern, and now we're going to add those babies up, and that's what it means to be a series. Okay, a series can be both infinite or finite. So a finite series would have like a certain number of terms. An infinite series would just go on forever, and we do both of these kinds, okay? We're going to use sigma notation to denote a series, and this is what we are not going to be afraid of, okay? It's not evil. Not at all. No. That was bad. We should not have even done that one. Okay? It's going to be amazing, this notation. So this is the sigma notation, okay? This is a capital Greek letter of sigma, okay? Sigma actually stands for a sum. That's what it stands for. It's very handy that both of those words start with an S, so it is easy to remember. And so this is our sigma notation, okay? Now, the way that sigma notation works is like this, okay? Let me see if I can get my little pencil going here. Where's my pencil guy? Pencil guy, here it is. Okay, so this guy right here, what you have your sigma. This guy on the bottom right here, this is called the index. This is just telling you what number you're going to start at, okay? This guy right here is your sequence rule. Okay, now this rule can be all sorts of things, right? So maybe that rule is arithmetic. Maybe that rule is geometric. Maybe it's just a random rule. It doesn't matter. The rule goes right here. And so when you're having to make some of these yourself, we're not even going to be freaked out about it, guys. You're just trying to figure out a rule to put there. So don't stress about it. Just think about what would be the rule to get each one of the terms for the sequence. That's what goes in that spot, okay? The top number up here, it doesn't say, but the top number is going to be the last term number that you're going to plug in, right? So you can see right here, we're starting with a sub 1, then a sub 2, then a sub 3, and then we just keep adding up the terms until we get to a sub n. So usually this a sub n up here is going to be, they're going to tell you what number to make it. So it'll be like a 10 or a 5 or a 7. Or this is fun, and this is what makes it infinite. They could put an infinity up there. Okay, so if they put an infinity up there, that's totally fine. Also, that just makes it an infinite series. Okay, example number 1 says we're going to express, okay, this guy using sigma notation. Literally, all you're doing for this guy right here, guys, okay, all you're doing is you are just writing a rule for this lovely guy and putting it in sigma notation, okay? So we start with the sigma, and we start by writing k equals 1 on the bottom. Got it, nailed it, super, looks so great. Okay, now right here is going to be a rule, and up here at the top is going to be how many terms there are. Well, I can just count how many terms there are, right? It's so easy. I mean, I only have to use one hand. Don't even have to take off my shoes. Oh my goodness. It is 1, 2, 3, 4, 5 terms. And so that 5 terms is going to go up there. So this is saying we're going to start by doing term number 1, and then we're going to do term 2, 3, 4, and 5. So we have 5 terms. Okay, so 5 terms, super exciting. This guy is actually alternating in signs. Can you see that? Look at that. This guy's positive, then negative, then positive, then negative. So in reality, it's like we're adding a negative guy. And then over here, we're adding a negative guy. So because the signs are alternating, the way that we do this mathematically is we do a -1 to a certain power. Okay, so this is going to be a -1 to the k plus 1 power. Typically, there's 2 versions when you do an alternating. Either it's -1 to the k power or -1 to the k plus 1 power. And you just kind of think about, like, is it starting with a positive or a negative? So as you can see in this guy, this first term, this 3 is in fact a positive 3. So we would need the first term to be positive, but I'm plugging in a 1. So if I did -1 to the first power, oh, that would turn out to be a negative number. So we don't want that. So we're going to do k plus 1 so that the first term ends up being a -1 squared. And then the second term would be to the third power, and it would be negative. Okay, so you just kind of have to think about which version, if it in fact is an alternating one. And then we got to figure out the rule. So then ignoring the positives and negatives, so just ignore those and just focus on the numbers 3, 6, 9, 12, 15. Doesn't that look like to you guys like multiples of 3? I think so. So our rule is going to be 3k. And guys, that's the answer. Like, this is it. Okay, the answer is the notation. Okay, that is not a box. Not even close. I'm going to erase that. I'm embarrassed. I'm super embarrassed. Like, who even drew that? Oh my gracious sakes. I can't even stand it. Okay, anyway, that's your answer, you guys. All right, so let's go ahead now and go to the next example. Okay, oh shoot. Guys, what is wrong with me? I am choosing the wrong little tools. Okay, I got it now. Don't worry. Okay, example number 2 says find the following sums. So this time they want us to write out the terms and then add them up, right? Because that's what it means to like basically evaluate this sigma notation right here. Okay, so the first thing we're going to do is we are going to plug in the first for a 1 for the J. Oh, Mrs. Fox, it's not a K. Whatever, doesn't matter. It's just the variable. You can pretty much use any variable that you want to. So the first thing we're going to do is we're going to plug in a 1. When I plug in a 1, I get a 1/2. Okay, what happens when I plug in a 2? Because I am plugging in the for the J value, a 1, a 2, a 3, and a 4. And why am I stopping at 4? Because it told me to stop at 4 right here in the top. Okay, so it says to stop at 4. All right, so we're going to put a 2 in now. So we do 1/2 squared. 1 squared is 1, but 2 squared is 4, so 1/4. Then we're going to plug in a 3. And if I do a 3, I get a 1/8. And then I'm going to plug in a 4 and I get the 1/16. Now, hello, do you have your calculator with you? Pause the video if you don't. Okay. You're just going to add these up. You could do it by hand, but why do that? You have a fraction button on your calculator. Of course, that guy is the best. And so just use your fraction button, go 1/2. So 1 ABC2, 1 plus 1 ABC4, et cetera, and you get an answer of 15/16, and that's your answer. So you have in fact evaluated this sigma guy right there. Okay, let's try another one. So this one says our rule is going to be t squared. Okay, it says we're going to plug in numbers starting with 0. Well, that's interesting, but still totally handleable. 0 all the way up to 7, and we're going to list them out and then add them up. So here we go. We plug in 0 and we get 0. We plug in 1. 1 squared is 1. 2 squared is 4. 3 squared is 9, 4 squared is 16, 5 squared is 25, then 36, then 49. And you'll notice all of these have plus signs in them because we're going to add them up because we're doing a series. And I plugged in all the terms. There's 8 terms. 1, 2, 3, 4, 5, 6, 7, 8, because I was going from 0 to 7. I add all of this up in my calculator. Tap, 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 tap. And the answer is 140. Quite lovely and very simple. Okay. This guy right here is called an infinite series. An infinite series. Okay, now how did I know that it was an infinite series? There are 2 hints to this. 2 of them, okay? One of the hints is that this up here has an infinity, and then also right here it says plus ... So we know that this baby is going on like forever, okay? So this is an infinite series. The sum of the first n terms of an infinite series is called the nth partial sum of the series, and you denote it by s sub n, okay? So even if they give you something where it says we're going to infinity, okay, if they just say, I want the s sub 6, that means I just want the sum of the first 6 terms, okay? And so they can do something called a partial sum. So partial sums are super handy. Especially when we get into like calculus and looking for certain patterns for stuff. So partial sums are pretty nice. Okay, so here's our first example. It says find the indicated partial sum. So it's telling us that we're going to find s sub 10 for this lovely series right here. Okay, but here's the problem. They did not write this in sigma notation, right? And they didn't even write 10 of the terms. Wow. That's a bummer. Okay, but instead, not a big deal. We're just going to write out all the terms, and then we'll put them in our calculator. Guys, so I think you can see the pattern. It goes basically a 3, a 6, a 9, a 12. They're all negatives, and so we're just going to keep on like subtracting 3 to get the other terms. So it looks like it's going to be minus a 15, and then minus an 18, and then a 21, and then a 24, and then hang on. How many terms am I supposed to have? Oh, yeah, I'm supposed to have 10 terms. So 1, 2, 3, 4, 5, 6, 7, 8, 2 more, minus 27 and minus 30. And so basically I just put all of these babies in my calculator, negative 3, minus 6, minus 9, blah, 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 and we get an answer of negative 165. So that is the 10th sum for this beautiful series that we had to actually write out a little bit. Okay, the next guy right here says s sub 6, okay? So you'll notice that this guy right here, it is an infinite series because it does have the infinity, but I don't care about that, like not even the teensy littlest bit. We are just going to do s sub 6, right? So we're just going to do 6 terms. So I'm going to start by plugging in 1 and then 2, 3, 4, 5, and 6 and add those numbers up together, okay? So if I plug in 1, I get 10 minus 6, which is 4. Okay, then I plug in 2, which is 20 minus 6, which is 14. And then maybe you can kind of already see what the pattern is going to be. 10 times 3 is 30. 30 minus 6 is 24. That's 3 of the terms. Then I'm going to plug in again, and I get 34, and then a 44 for the 5th term, and then the 6th term is, in fact, a 54. I add all of those babies up, and the answer is 174. Yay! Woohoo! So easy! Okay, so I don't know about you, but I was kind of getting like annoyed that I had to write out all of these terms, and then I had to write out all of these terms, right? Like, oh, is there like a better way? Please, Mrs. Fox, please tell me that there is a better way that we can add these babies up. And like, of course there is. Yes, of course there is. Okay, depending on if the term is geometric or arithmetic, we actually have like kind of like a cute little formula, which I want you to memorize, okay, that you can use to quickly find the sum. And like we only did like 10 terms and 6 terms. What if it had said, oh, gasp, 100 terms? Oh, how evil would that be if I decided to make you sum up the first 100 terms of something? Like, come on, Mrs. Fox. So nope, even if I said that, it'd be so easy because now we have some cute formulas, okay? So this first one is for an arithmetic sequence, okay? So if you have an arithmetic sequence, of course, an arithmetic sequence has a common difference of D, okay? The way you get each term, this is a review. This is for, oh my goodness, what did I just do? I just drew on my paper. I mean, seriously, Mrs. Fox, what is happening right there? Oh, wait, let's start that again. Okay, so this guy right here, okay, this guy is, in fact, how you get a term, okay? So this is, we learned this yesterday, and so I think it was yesterday. Well, it was a previous lesson anyway. So this is a term for an arithmetic sequence, and so if this is how you get a term, this is now how you would get the sum. Notice that it says S sub n, right? S sub n means we're getting a sum. And so it is n. N stands for the number of terms. So if you want to make a note for yourself that n stands for the number of terms, and then you're going to multiply by the sum of the first term, which is a sub 1, plus the nth term, which is your last term, whatever the n is here. So say it says s sub 100, then it's the first term and then the 100th term. You add those up, multiply by how many terms there are, and then divide by 2. Now, there is also an alternate formula to this guy. Like, seriously, there are two of them. I mean, in mathematics, we can have two of things, like, whoop, whoop, super exciting. So this other one looks like this. Okay, now you may be like this. Oh, yes, Mrs. Fox. No, 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 that looks horrible. But no, it's actually quite lovely. Literally, all they did, okay, I'm going to let the cat out of the bag, just whoops, I meant to do the laugh button, just to share with you guys. All they did is they took the formula for a sub n right here, which was this guy, and they put this guy in instead. So they took this entire formula and put it in instead of the a sub 1 and then combined some terms. So it turns out to be s sub n is the n times 2 times a plus 1, because we would have 2 of those, and then plus the n minus 1 times d all over 2. So, like, honestly, guys, which one's better? Like, I don't know, both of them? Sometimes it's just nice to have options. I guess it kind of really depends on, like, what information that they give you. So if they, like, totally give you a rule and you're able to figure out the first term and the first term and the last term, like, if you're able to very easily figure this first term out and then figure out the last term, then, like, dude, that's totally the one you should use. Like, obviously. Duh. Okay, but however, if they don't give you that, maybe they just give you some of the terms, maybe it's just easier to figure out what the common difference is and then just double the first term. So honestly, I think probably what we're going to do is use both of them. Which one do you use? I don't care. Just get it right, guys. Okay, so pick either one that you want to. It doesn't matter to me, okay? So this is example number 4. It says find the indicated partial sum. It says for S sub 8, and it looks like to me that this is the sequence, and they want us to find the indicated partial sum. So let's kind of look at the numbers. If you have a 15, then a 9, then a 3, then a negative 3, it looks like, guys, it's an arithmetic sequence, right? For sure. And it looks like the common difference is we're going down by 6, okay? So what I'm thinking on this one is I'm going to use this formula. They didn't quite give me the rule, and I don't want to take time to find the rule. So instead, we're just going to use the first term right here, this 15. So I'm going to grab that 15, and then I already kind of like visually figured out that the common difference is just going to be 6. And as long as I know both of those items, like, boom, ooh, totally done. It's going to be amazing. So let's go ahead and do it. So the number of terms is going to be 8. So notice, guys, okay, I know I just popped up a lot of things here, but this S sub 8 is S sub 8 right here. The number of terms right here in the front is an 8. So then it was 2 times 15, because 15 is the first term, plus 8, there's that n again showing up, 8 minus 1 times negative 6. It's just a matter of doing the right order of operations, like, of course. I'm thinking about doing 8 minus 1 is 7. 7 times negative 6 is a negative 42. And then I have, like, 2 times 15 is 30. So 30 and negative 42. Multiply by 8, divide by 2, and ta-da! That's it. Negative 48 is your answer. Okay, so this formula is super duper duper handy. Now, if you were doing this on your own and you were like, dude, I am so not doing that formula, then don't do the formula. Like, seriously, no one cares. Just get the right answer. Okay, let's try the next one. Okay, this one says S sub 24, and it's an infinite series, but that doesn't matter to me because I'm still just trying to find the, where did my little pencil go? Sorry, I'm just trying to find the 24th sum. So this, like, that's fine with me. Doesn't matter. I do know that there's going to be 24 terms, but check it out, guys. Look what they gave me right here. Oh, do you remember at the beginning of this lesson that I said that basically in this spot, this is just basically where the rule goes? Okay, so this is in fact the an arithmetic sequence rule. And so I'm just gonna, I think, do the first term and the last term on this one, right? Because I could just plug in 1 for the first term and then plug in 24 for the last term. Digging it. Okay. So this says S sub n. This is the formula we're going to use. Remember, we just wrote it down. It's probably, you can see it on your paper. So n times first term plus last term all over 2. So here we go. Then the number of terms is 24. The first terms is negative 4.5. How did I get that? I took 1 and plugged it in for t right here in this spot. And so 1 times t is just 1.5. And I subtracted 6 and I got negative 4.5. So there's my first term. Okay, and then how did I get 30? Well, that's my last term in this sequence. And I'm going for the 24th term. So I did 24 times 1.5. I got 36. And 36 minus 6 happens to be 30. So ladies and gents, I'm just going to take my 30 and my negative 4.5, add those together, multiply by 24, divide by 2, and just like that, I get an answer of 306. Okay, so these formulas are so handy. And guys, I'm not kidding. You seriously need to start memorizing these, okay? The more you memorize them, what I would do probably, like, just like trade secret here, I would probably write it down every time that you do a problem, because then it'll help you memorize them. It's just like that repetition, okay? Fun fact, my dad always likes to say, repetition is the key to learning. No, he actually like totally says that, probably a little bit too much, but you know, then I remember it because he repeated it over and over again. Okay, back to our regularly scheduled programming of figuring out a formula for a geometric series. Okay, so there's also one for a geometric series. The geometric series for a sum, okay? So if this is our geometric series, right, a sub 1, a sub 2, a sub 3, if it's a geometric sequence, with our common ratio r, we know that the formula that we talked about yesterday, so this guy right here, remember, this is the formula to find a term of a geometric sequence, okay? We take the first term, and then you have your common ratio, which I really hope that you've been putting in parentheses, right? Like, of course, parentheses, and then raising it to the n minus 1 power. So if that is how our geometric sequence looks, the sum for the geometric sequence is this. I'm going to be honest with you. This is probably the most complicated one, but it is like kind of like, I don't know, kind of cute, I think, right? It's really cool looking. So it is our most complicated one. And so you're going to want to like really spend some quality time with this guy. So S sub n, our nth sum is going to be our nth partial sum is the first term, okay, times 1 minus r to the n. So whatever the common ratio is, you raise it to the n power and then go 1 minus this guy all over the quantity of 1 minus r. Honestly, you just like super need to watch your parentheses in your calculator on this one, okay? So when we do these examples in the notes, can you please do it with us just to make sure that you know how to work your calculator and the parentheses? That would be like the best idea, okay? So that's a super, yes, please do that. Okay, so this one says find the seventh partial sum for this series of, whoa, this is a crazy series. Let's write this baby down. It says there's a 1. Where's my pencil guy? Here's my pencil guy. Okay, there's a 1. Then there's a minus a 0.8. Then plus a 0.64. Then minus a 0.512. So first of all, I got to figure out what the r is. I already know what the first term is. Like, okay, yeah, duh, it's 1. Okay, but what is going to be my r? Like, that's the question. So remember how in a previous lesson, if you want to figure out the r, you just take a second term and divide by the first term or one before it. So you could either take negative 0.8 and divide by 1, which is actually kind of easy. Like, that's not even difficult. It's totally negative 0.8. Or if you were feeling jazzy, you could have taken 0.64 and then divided by negative 0.8. It doesn't matter. Our r ends up being negative 0.8. Okay, so r is negative 0.8. And guys, that's all the information you need. The first term and the r. And now you just have to shove it in your calculator in the most proper way. So this looks complicated, but it's actually just plugging in all of the numbers. That's it, guys. Okay, so we're just plugging in the numbers. And so here's the first term, right? The first term is a 1. And then we go 1 minus. We have negative 0.8 raised to the 7th power. And if you're doing that in your calculator, folks, that needs to be first. And the negative 0.8 needs to be in parentheses, okay? And then divided by the quantity of 1 minus negative 0.8, which probably you could just change both of these to a plus really fast and make that be 1.8, one less calculation for you to like use parentheses for. So in your calculator, I'm going to sort of walk you through it super quick. You're going to do parentheses around a negative 0.8, close the parentheses, raise it to the 7th power. Then go 1 minus that answer, multiply by 1, and then divide by your 1.08. And just like that, we get an answer of 0.672064. That's what it says it is. We got it, okay? So just like that, we're good to go. I'm pretty sure we just have one more example, and it's a word problem, right? No. Don't think about that. Think about it more like this. We got this, right? Just because it's a word problem doesn't mean anything. We know that it's either going to be arithmetic or geometric, so let's figure it out, okay? So it says Mark's grandmother gives him $100 on his birthday every year. So generous. Pretty sure my grandma did not give me $100 on my birthday. Nope. Mark must be very lucky. Every year, starting with his third birthday, and then they put it in an account, and he's not allowed to touch it, right? Just not allowed to touch it, and it earns 7.5% interest. Okay, so what we need to think about is when you earn interest, you're doing some sort of multiplying. So then you're like, ooh, yeah, this is going to be a geometric one. Okay, so this is going to be a geometric series. Okay. So our first term is totally 100, okay, because that's the first amount that we put in. Our R is 1.075. Okay, Mrs. Fox, I kind of know where the 0.075 came from, but where did the 1 come from? We're thinking. Okay, so maybe you're having a thought that is because you have to multiply, okay? You have to multiply and take your original amount plus the interest. Okay, so that's why that is. I don't know if you remember back in the day, you've done this sort of formula before. You go like 1 plus, I think we did it in the log chapter, and it's like 1 plus like R over N. Do you guys remember doing that like that? Okay, so it's kind of like what we're doing, except for we're not really using this N part. We're just using this R part. And so you do end up multiplying by a 1 plus R. So hopefully that maybe jogged your memory just a little bit. Be like, ding, ding, like, oh yeah, that does make sense. Okay, so the question says, how much is in the account the day after Mark's 10th birthday? So remember, like on his 10th birthday, he would get another $100. And so we got to think about how many terms this is, etc. Okay, so let's talk about this. Why in the world? Okay, so some of this makes sense to me, and then some of it is like a little bit of a question mark for me. Okay, so one of the things that makes sense is that it says 100. Okay, whoops, I'm totally drawing in the wrong spot. Okay, that it says 100 right here. 100 is the first term. Love it, okay? 1.075 is totally my rate, my common ratio, what I'm multiplying by. So having that there and there makes perfect sense. I might even like put this in parentheses just to be safe and to have some continuity, okay? But why in the world is this an 8? Okay, so now we have to think for a little bit. The first time it happened was on the 3rd birthday, okay? And then we're going every birthday up till we get to 10. So we have the 4th birthday and the 5th and the 6th. I'm so sloppy. Doesn't really matter. The 7th, the 8th birthday, the 9th birthday, and then the 10th birthday. And so guys, let's count how many terms that is. Okay. That is 1, 2, 3, 4, 5, 6, 7, 8. Guys, that's why it's 8. Okay. We have 8 terms. And so we're going to find the 8th sum. Okay, so that's what we're doing that, and that's why this power up here is to the 8th power. Again, you just really watch how that goes into your calculator, and I'll give you like 2 seconds, 5 seconds to go ahead and put that in. So let's build it up. Let's do a little drum roll. You're putting it in your calculator, and you get an answer of $1,044.64. Okay, that's actually pretty amazing. I wish my bank account had that much interest. That would be amazing. Okay, so ladies and gentlemen, that brings us to the conclusion of the lesson. We did it. Good job. Us. I'm so proud of us. Another lesson completed, brought to you by Patio Productions. And so this is your homework assignment. I'm definitely going to post that into Google Classroom. Remember, you are taking a picture of your homework and posting it in Google Classroom. And I think that's about it, guys. That is our last lesson for the week. Let's get it done. You know what I'm saying? So that's it. We'll have some music to send you off with. And I hope you guys have an amazing day. I miss you. I love you. And I can't wait to see you. Bye. See you later.